So, last day of finding zeros for polynomials. Yay! Okay, so let's summarize what we've done so far, right? So we've done 4-term polynomials, like we did here. What methods do we solve that with? Grouping. Okay. Always remember, first of all, for every method, check your greatest common factor, right? That's your number one on every polynomial you see. Okay. So 4-term polynomials we can group. Okay. 3-term, that would be something like what we did earlier. Okay. How do we solve those? Let me count the ways. Okay, so we can factor it, right? And we can complete the square. What else? Yeah, that would be a part of factoring. Okay. Quadratic formula. Graphing. Can we graph these? You can graph them, you just may not get exact answers. Okay. Factoring methods, we did Punnett square, and we also did guess and check. And we also have the greatest common factor there, right? That you can factor out. So, okay. What did you say, Shira? I was writing something and you said something. Okay. Synthetic division's an option if you have a factor, right? Right. So if a 0 or factor is given, we can do synthetic division. Okay. Is that all the 3 terms? Oh, quadratic form, right? If this is like a 4th. So if this was 2x to the 4th plus 7x squared plus 3, you know, that's quadratic form factor. Hey, turn the sound off, please. Thank you. If we're going to be immature about it, we could just turn it off. And then 2-term is what we're going to tackle today. Okay, so always remember your greatest common factor there, but we're going to do that today with their formulas, right? And they're pretty straightforward, so that's so far. It's a lot to remember, isn't it? Put it on your blue sheet. I'm not requiring that you memorize these. It would be beneficial for you because next year you don't get a blue sheet in calculus or stats. Okay. So have these in your brain. We will touch on them all again at the end of the year. It's like we take a week and we do all these again to review. So, okay, 2 terms. We are looking at something like this. This is called the difference of 2 squares. You got the difference of 2 math nerds. It's probably going to look familiar. It's the cubics that you probably haven't seen yet. Is there an x term?
Yes.
Yep.
There's an x squared term?
No.
Is there an x term in here? No, there's 0 of them, right?
Yeah.
So if you need to, you can rewrite this and factor it. So what are my factors? Right?
It's in the year for.
Oops. Thanks for that. Okay, so plus 2 minus 2, right?
Right.
You can avoid rewriting that and recognize that this is a squared, and there's a difference, right? We call it the difference of two squares. And your formula is a plus and a minus. So the difference of two squares. Yes?
What happens when x squared plus 4?
We'll get to that. Okay. So, very simple formula there, right? You can make it more complicated if necessary. Like I could write 4x squared minus 25 . Is this still two squareds?
Yes.
Yeah, so what's this term squared?
2x.
Yeah, 2x squared minus,
5 squared.
so what are our factors? Da 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 da, 2x minus 5,
Good thing.
2x plus 5. It's just these terms. Okay. Good? Or bad? Okay. Try this one. Okay. Can I write this as a squared? Okay, the x obviously is squared. What is the 2 though? Nope, 2 squared is 4. Do not have a 4 there. You think in terms of roots and squareds. There it is. Okay, so be very aware that that can happen, because it just did. That's 2y, right? What's root 2 squared? 2. So if you have a number here that's not a perfect square, you can just put the square root of that there. Okay, but this 4 is a perfect square, so the square root of it's 2, right? So be aware that that can happen.
So that's your answer?
So factor it. Root 2x minus 2y and root 2x plus 2y. Okay. So difference of two squares. That's it. You're factored. All right. Sum. Caleb asked about this. Factor. And? X plus 2 and x plus 2? It gives you a middle term.
X minus that minus 4
So then it has to be plus 4
So it'd be
X squared
minus 2.
plus 0x plus 4. Is there anything that multiplies to 4 adds to 0?
Positive
Oh,
to
no.
negative, yeah.
Yeah, but that would make minus 4. Positive times the negative is minus 4. This is not factorable.
So it's never gonna be a problem.
Yep, if you have the difference of two squares, it's not factorable. End of story. Deal? All right, moving on. Okay, difference of cubics. Are those both cubics? It's 2 cubed, right? Okay, the question is, how do you factor that? It's just an algorithm you have to follow. Okay, and this one I have to look up every year because I don't memorize them. Right? It's just not a big deal. So, difference of cubes is x minus y, and then we have pluses. So, x minus 2, right? And then x squared plus 2 times x, and then plus negative 2 squared. So, let's see here. Make sure that's right. Nope, it's just xy. Okay, erase one of those 2's. Let's color code. The x goes here, here, and here. Right? And that should not be negative. And we're having a banner day. That's what happens when you don't get enough sleep. The 2 goes here, here, and here. You're just placing those in the right spots. Paying attention to
That's 4.
the signs.
Why is there, what does that mean? Negative 2 to the 4?
What?
Because it's 4 too. Yeah, but that's 2 squared plus 4 times
Minus 8. 4 times negative 2 is
yeah.
negative 8. That's where that comes from.
And what do you do with the 2?
Basically what happens is you end up with x and x squared and negative 2 and 2 squared, and everything else eliminates. That's the beauty of that formula. Okay.
And what do you do with the 2 times x?
It's a, so what's your final x squared plus 2x plus 4? That's your final factored polynomial. If you have a difference of 2 cubics, this is the formula you follow right there. And it generates your factors. Okay. Can I factor this any further? No, I can't. And that will usually be the case. Okay. So you're just putting each of these terms in the right spot, and you're good to go. But, and it will give you a factor, right? What could I do with this factor?
Could use synthetic division.
Yeah, you can use synthetic division now to simplify that, right? If you need to, if you're looking for zeros. So just use the formula. That's my advice. Write it down and just know how to use it.
So,
Okay. It does not come up very often, but it is a tool we have in our toolbox. Okay.
so the formula is.
Yeah. So this x here goes, and then the 2 goes here, here, and here.
If it was x to the 4, so it would be the formula.
We don't have that. This is only for cubics. You have to have 2 cubics. Right? So, let's see. are those 2 cubics?
Not yet.
They are. Rewrite it as, what's this one going to be? 2x, right? So we're cube rooting. 2 cubed is 8. And then what is 64? Yeah, 4. Now you take each of these and just put them in the right spots. Yep, I can. Okay, where does the 2x go? Here? And that's square, or that's just it, right? It goes here, squared, and it goes here, right?
Shouldn't it be
I feel like
4
I'm in
times
a
X?
little boy's nursery. What?
Wait, shouldn't it be 4 instead of 2?
Yeah.
Where?
Right after the 2x squared.
Here?
Yes.
That's, I've just placed this term.
You shouldn't have.
Yeah.
It should be good. It's 2 times x, like on the first one.
It doesn't matter.
It's 2 and x.
It doesn't matter.
It doesn't matter. Multiplication is commutative, they can switch order. And then we're going to place the 4, right? Minus 4, 4, and 4 squared.
What is it on the, isn't that the one in the middle, x y, or not 2xy? Should be just 4x.
It's this term
Well, because it's
Oh, yeah.
times this
right.
term. Yeah, right. So this was x times 2. This one's 2x times 4 in the middle, right there. Yep, so just place your terms accordingly. And then rewrite it because it does make it a little bit nicer. 2x minus 4, 4x squared plus 8x plus 16. Right? Okay, that's the difference of cubics. Just be able to use the formula. Can you follow directions? That's the question here. I sense confusion. But I guess we'll see. Now, the difference of, or the sum of 2 cubes is very similar. So, same example as before. All you're going to see is a sign difference. Okay. The difference of 2 cubes was minus plus plus. It's going to be plus minus plus now. That's it. Okay, so the only difference is, so this is 2 cubed, right? It's x plus 2, x squared minus 2x plus 4. So there's just a sign difference.
Shouldn't it be 4?
It's 2 squared. I just didn't write it that way. So we have x, and we have the 2. 2 squared. Same structure, just different signs. Okay. Is there a moose in here? You sound like a moose. Is that you?
Wait, would it be minus 4?
Oh, it's plus minus plus. Yeah, so. Thanks for the laugh, Kellen. It's getting kind of intense in here. I'm trying to think if there are any other, anything more difficult that you need to be able to work through. That's about all I can show you. You give them a shot and see if you can do them, and if not, we can work on it. Are you two okay? 'Cause you're like looking at a little boy's nursery, like literally. High fives and frozen Gatorades, I can't stop.
They're excited about math.
Yeah.
Okay, thank you, Kellen. Bailing them out. Would you like to do a calculus problem about the rate at which that ice will melt? Yeah, you should.
You know how some kids are dropping their brother's kid? He's got plenty of balls. What happened to me?
Okay,
Excellent point.
the worksheet's posted. Sum and difference of cubes. Whoops, I better just write that. One, 5, 11, 13. Okay, and then factoring all techniques. So you're going to have to draw on all of the techniques that we talked about as a summary. And we did a summary, so think through those 3-term, 4-term, and 2-term factoring techniques.
So what does that worksheet do? All of them?
And that's, so you've got 9 problems tonight to work. Okay. The big thing here is, can you look at a problem? Obviously, we're not going to hand you, you get to the point where you don't get to say factor by, or solve the zeros by completing the square. Right? You get to the point where it's just solve this equation. You have to choose how to do that. That's why the value of this right here, that's why they give it to you. Because you have to analyze the problem, think it through, choose your method, and execute it. Okay? So get some practice there. It's a very good critical thinking and problem solving skill. All right? And that's why I only gave you 9 of them. Yep. So tomorrow we solve rational equations. Friday, radical equations. They're really radical. They're cool. I'm pretty sure you have a test next week. Thursday, probably.
Pretty sure.
Yep. Pretty sure. Would you like me to be 100% sure?